Global exports of semiconductors to Russia have plummeted by 90% since the country's invasion of Ukraine and the ensuing sanctions. Once busy car factories have fallen idle, with output collapsing to the lowest levels since the Soviet era. In desperation, Russian technicians have reportedly salvaged chips from dishwashers and refrigerators to use in military equipment. These startling facts point to a technological implosion unfolding in real time. How did a major world power, with a legacy in science and engineering, reach a point of complete dependence on foreign semiconductors? How did Russia become so isolated, a pariah state in the global tech ecosystem, that it must cannibalize home appliances for microchips? The collapse of Russia's chip industry is a story of historical setbacks, sanction shocks, and a last-ditch lifeline from China. It raises a pivotal question. Can Russia rebuild a self-sufficient semiconductor sector, or is technological sovereignty now out of reach? Russia's current woes have deep roots. The Soviet Union poured resources into microelectronics during the Cold War, seeking self-reliance in computing and military tech. By the 1960s, Soviet labs in places like Leningrad were turning out transistors and chips for rockets and satellites, reportedly keeping fairly on par with Western tech for a time. In the 1970s, Soviet chip plants like Micron even delivered millions of integrated circuits annually, including components for space missions and early supercomputers. However, these achievements masked a growing gap. By the 1980s, amid economic stagnation and tight Western export embargoes on high-tech goods, the Soviet industry largely fell behind and resorted to reverse engineering Western designs. Soviet chipmakers copied IBM mainframe circuits and other foreign microchips, trying to catch up without access to the latest tools. This strategy could not sustain innovation. In truth, Soviet chips lagged years, even decades, behind leading-edge products from the United States and Japan. When the USSR collapsed in 1991, its semiconductor ecosystem fragmented and crumbled. Many key microelectronics facilities ended up outside Russia, in newly independent republics like Ukraine and Belarus. The factories that remained in Russia were suddenly exposed to global competition and a flood of cheap imports. The result was a near-total collapse of domestic chip production in the 1990s. As one analysis notes, the Soviet-era industry collapsed in the early 1990s, and imports took over practically all of Russia's microchip supply. For almost 2 decades, Russian device makers simply bought their semiconductors from abroad rather than rely on dwindling local fabs. By the 2000s, Russia's share of global semiconductor output was effectively zero, and even its share of consumption was minuscule, less than 0.1% of global chip purchases in 2021. In the booming world of Silicon Valley and East Asian foundries, Russia was a bit player. Moscow did make some attempts to revive microelectronics during the 2000s, but with limited success. Underinvestment, brain drain, and easier profits in oil and gas meant chips were not a top priority. There were a few bright spots: collaborations with Western firms to bring in slightly modern production lines. For example, the Micron fab, a Soviet holdover in Leningrad, partnered with ST Microelectronics to install a 180-nanometer process in 2007, and by 2012 it had a licensed 90-nanometer lineup and running. These nodes were generations behind industry leaders, which were at sub-30 nanometers by then. But they allowed Russia to make basic chips like secure ID cards and SIM cards. Micron even developed a pilot 65-nanometer chip by 2014. However, quality issues kept those from mass production, and the project ended up contracting manufacturing to Taiwan's TSMC. This pattern became common. Russian firms could design chips, but had to rely on foreign foundries to actually build them at anything approaching modern standards. By the 2010s, Russia did nurture a few domestic chip designers. MCST, Moscow Center of Spark Technologies, produced the Elbrus line of CPUs, bespoke processors with a unique architecture aimed at government and military use. Baikal Electronics designed ARM-based processors for PCs and servers. Yet, tellingly, both MCST and Baikal depended entirely on TSMC's fabs in Taiwan to manufacture their chips. Elbrus and Baikal chips were fabbed at 28 nanometers in TSMC's Hsinchu facility, technology current in 2011, not cutting edge by the 2020s, but far beyond what any Russian fab could do. Plans were even made for Baikal's next-generation processors to use 16-nanometer TSMC tech, but those never reached mass production. In short, Russia entered the 2020s with some intellectual know-how in chip design, but minimal domestic manufacturing capability. The legacy Soviet fabs like Micron were stuck at 90 nanometers, at best 65 nanometers, in small volumes, suitable only for low-end microcontrollers and Soviet-era military chips. Anything more advanced, from laptop CPUs to automotive microcontrollers, had to be imported or fabricated abroad. This reliance was not perceived as an urgent problem during times of open trade. Russian companies freely bought Intel, AMD, and Nvidia chips. State firms ordered specialized chips from TSMC. Factories imported microcontrollers from Europe and Asia. There were missed opportunities, chances to invest petrodollar windfalls into modern fabs, but these never materialized. Instead, Russia's tech sector grew comfortable importing what it needed. By 2021, Russia was importing about $1 billion worth of chips annually, mainly from suppliers in China, Taiwan, and Europe. Local output met only a small fraction of demand. This delicate status quo might have continued had geopolitics not intervened in 2022. The events of that year would expose the fragility of Russia's semiconductor position, triggering the utter collapse we are witnessing now. Russia's invasion of Ukraine in February 2022 was a watershed moment for its high-tech industries. Within weeks, an unprecedented array of international sanctions and export controls cut off Russia's access to critical chips, manufacturing equipment, and software. The country was essentially severed from the global semiconductor supply chain. US tech companies like Intel and AMD halted sales of microprocessors to Russia. Major chip-producing nations including the United States, European Union members, Japan, South Korea, and Taiwan all imposed sweeping export bans on advanced semiconductors and fabrication tools bound for Russia. The Semiconductor Industry Association noted that its members would fully comply with the new rules, even though Russia had been a very small market for chips. One immediate blow came from Taiwan. As the world's top contract chip maker, TSMC was manufacturing nearly all of Russia's domestic chips, the Elbrus and Baikal processors, before the war. In sync with US sanctions, TSMC swiftly halted all production and shipments for Russian clients. This meant MCST and Baikal Electronics were left with nowhere to fabricate their designs. Russia's highest performance chips, which were already a couple of generations behind world leaders, suddenly had no supply at all. Plans for new 16-nanometer Baikal server chips were shelved indefinitely. As one Russian analyst put it, the Western sanctions dealt a major blow to these CPU design firms. Years of work and state investment in Elbrus CPUs evaporated overnight when their TSMC lifeline was cut. Almost every avenue for obtaining advanced silicon was shut down. In June 2022, Taiwan officially banned exports of any chip more advanced than 25 MHz or 144 pins to Russia, effectively covering almost all modern processors. At the same time, the US instituted a novel rule. Any chip made with US technology, which includes the majority of chips globally, was forbidden to Russia. This meant even non-American suppliers had to comply or risk severe secondary sanctions. Japan and the Netherlands, the key makers of semiconductor production equipment, joined in with their own bans by 2023. The Dutch firm ASML, which dominates lithography machinery, announced it was no longer servicing or selling any equipment to Russia. Even older models of lithography machines that Russia might use fell under restrictions. In fact, when Russian firms tried to source spare parts for 25-year-old ASML machines through intermediaries, they had to sneak them in via China to dodge EU sanctions. The Western export controls targeted every choke point of the chip-making process, from design software to fabrication tools to the chips themselves. Companies like Cadence, Synopsys, and Siemens ceased providing EDA, electronic design automation, software support, which is vital for designing new chips. Even ARM licenses were withdrawn. Britain sanctioned Baikal Electronics in 2022, ensuring that no new ARM architectures or updates could be provided to that Russian firm. Without EDA tools and IP licenses, Russia's chip designers were left using outdated technology with no easy way to upgrade. Crucially, no advanced chip fabrication equipment, lithography scanners, etching machines, etc., can now be legally exported to Russia, throttling any plans to upgrade local fabs. By design, these restrictions aim to choke off the flow of technology to Russia's defense industrial base and cripple its warfighting ability. The impact of these measures was swift and sweeping. By mid-2022, US officials reported that global semiconductor exports to Russia had fallen by 90%. In other words, Russia was receiving only a trickle of the chips it used to import. Civilian industries were hit hard. Russia's automotive sector, for example, essentially went into freefall. Production slumped 67% in 2022 as Western automakers pulled out and critical components, like engine control chips and sensors, became scarce. Factories literally stopped mid-assembly due to lack of imported electronics. The aerospace industry faced a similar squeeze. Without Western avionics and chips, maintenance of aircraft became so difficult that Russia's commercial airlines are predicted to ground large portions of their fleets just to cannibalize spare parts. On the military front, the sanctions sought to degrade Russia's precision weapons and communications. Russian defense companies could no longer directly buy the high-performance analog-to-digital converters, FPGAs, and microcontrollers used in everything from cruise missiles to encrypted radios. The U.S. Commerce Secretary, Gina Raimondo, noted that Russia's ability to manufacture and repair military equipment was being crippled by the technology denial. Indeed, Western investigators who examined Russian weaponry captured in Ukraine found that the vast majority of critical microelectronic components were of US, European, or East Asian origin. With those supply lines cut, Russia's defense industry was forced into a scramble for alternatives. Perhaps no example illustrates the shock better than the fate of Russia's proud, domestic chips. Elbrus, the CPU meant to power Russian government computers as an alternative to Intel, had been fabbed in Taiwan at 28 nanometers. When TSMC pulled out, MCST attempted to move Elbrus production back to a Russian fab. The only candidate was Micron, stuck at a much older 90-nanometer node. In May 2022, MCST and Micron officials met to discuss making Elbrus chips on the 90-nanometer process. This would be a huge technological downgrade. 90 nanometers is roughly 15+ years behind 28 nanometers, sacrificing performance and efficiency. It highlighted Russia's lack of options. To use Micron, Elbrus designers would essentially have to turn back the clock to 2000-era technology, a stopgap at best. Even that plan was fraught with difficulty. Micron's capacity was limited, and it lacked experience with such complex CPU designs. As of 2023, there is little evidence that any significant volume of Elbrus has been produced at Micron. The future of that line remains in limbo. In summary, the post-2022 sanctions delivered a devastating shock to Russia's chip supply chains. Virtually every pipeline for obtaining advanced semiconductors, or the means to make them, was sealed off. Russia's tech sector was left to improvise solutions with older technology, alternate trading routes, and the faint hope of self-sufficiency. The immediate response to this isolation was telling. Russian industries began to cannibalize and improvise on a national scale, as we examine next. Cut off from cutting-edge imports, Russia started to strip mine its existing technology to keep the lights on. Reports emerged of Russian manufacturers repurposing microchips from everyday appliances to use in more critical applications. In spring 2022, US officials revealed that when Ukrainian forces inspected captured Russian tanks and drones, they found components taken out of dishwashers and refrigerators inside. Those were Commerce Secretary Raimondo's exact words to Congress. Russian military gear was being repaired with kitchen appliance chips pulled from civilian goods. By late 2022 and 2023, this almost sounded like dark comedy. But it was the reality of Russia's sanctions-hit military. The Russian military is cannibalizing chips from washing machines to support its war effort, as the US ambassador to the EU put it bluntly in 2024. In modern guided missiles that once used specialized American-made semiconductors, engineers were now apparently soldering in whatever generic chips they could scavenge from retail electronics. The performance and reliability of such MacGyvered solutions were dubious. Western analysts noted a deterioration of the technology in Russian weapons over time as high-grade parts ran out. The broader economy faced similar jury-rigging. Nowhere was this more visible to ordinary Russians than in the automobile sector. By mid-2022, consumers noticed new domestically made cars coming without previously standard features. AvtoVAZ, Russia's largest automaker, launched a 2022 Lada Granta model that lacked airbags, anti-lock brakes, stability control, and modern emissions controls. The reason was simple. Those features all rely on imported electronic components and sensors that were no longer available. The new Lada was basically a 20th century car sold in 2022, stripped of safety and environmental tech. Its engine met only 1990s emission standards. This regression was officially authorized. The government even loosened regulations to allow production of cars meeting the bare Euro 0 standard. No airbags, no ABS, due to the shortage of electronics. Russian car output fell to a trickle, and what did roll off the line was a shadow of modern automotive technology. The Russian government initially responded with bravado, touting import substitution and technological self-reliance. State media and officials insisted that domestic companies would step up to produce needed components and that parallel import schemes, buying Western goods through third countries, would fill the gaps. However, these promises often rang hollow. In practice, parallel imports could not fully compensate for the loss of direct high-tech shipments. A government scheme to allow grey market imports without IP owner permission helped bring in some consumer electronics, but for specialized semiconductors and machinery, it barely moved the needle. By and large, the high-performance chips and tools Russia needed were tightly monitored, and many third countries were wary of re-exporting sanctioned items. Contradictions in policy started to show. Even insiders in the Russian establishment began to acknowledge the impossibility of full self-sufficiency. Sergei Chemezov, the longtime Putin ally who leads Rostec, the state defense tech conglomerate, gave a striking warning in June 2022. He wrote that replacing everything is senseless, economically impractical, and simply impossible, noting that total technological isolation is a road to nowhere. This admission, from a top architect of Russia's tech policy, underscored the dire straits. Chemezov openly criticized the notion that Russia could just replicate all the foreign tech it lost. No country in the world, he argued, even attempts complete autarky in microelectronics. Coming from Rostec's chief, responsible for many import substitution projects, this was a sobering dose of reality. Meanwhile, frontline consequences continued to mount. In sum, the sanctions-induced isolation forced Russia into a corner where making do with whatever chips could be found became the norm. From consumer goods to missiles, many systems were downgraded. This cannibalization kept some machines running in the short term, but it was clearly unsustainable and a sign of systemic breakage. Realizing this, Russia increasingly turned to the one major source of electronics still willing, to some degree, to trade with it: China. Next, we examine how China stepped in as Russia's semiconductor lifeline, and why that lifeline comes with serious limitations. With the West closing its doors, China emerged as Russia's critical supplier of chips and electronics after 2022. Moscow and Beijing have drawn closer in a shared strategic alignment, and this has extended to technology trade. Almost immediately after sanctions hit, Russian imports of Chinese semiconductors skyrocketed. In 2021, Russia imported roughly $200 million worth of chips from China. In 2022, that number jumped to well over $500 million. By late 2022, China had become by far Russia's largest source of semiconductors, accounting for more than half of Russia's remaining chip imports. It wasn't only mainland China. Hong Kong also played a major role as a transshipment hub. Technically a separate customs territory, Hong Kong saw an explosion of chip exports to Russia. Hong Kong's shipments of integrated circuits to Russia doubled to around $400 million in 2022. Combined, China and Hong Kong provided nearly 90% of Russia's semiconductor imports in the months following the invasion. Much of this trade involved illicit or grey channels. Western-made chips, from US and European brands, were being funneled to Russia via Chinese intermediaries. For example, one analysis found that exports of US-branded chips from China, HK, to Russia increased tenfold between 2021 and 2022, reaching about $570 million. In other words, Chinese traders were helping route-banned Western chips into Russia's hands, despite the export controls. Beijing's government has tacitly supported this lifeline. While Chinese officials claim compliance with official sanctions, and indeed major Chinese tech companies have been cautious, China has not joined the sanctions regime and has allowed its firms to fill the vacuum. By 2023, estimates indicated that over 80 to 90% of all chips Russia was importing came from China. This heavy dependence represents a major realignment of Russia's supply chain toward a single partner. Chinese companies also started supplying Russia with more electronics components of their own make. For instance, Russian firms began buying Chinese microcontrollers and basic processors to replace Western ones in industrial machinery and cars. Chinese consumer-grade chips, the kind used in smartphones, TVs, and cars, became Russia's interim solution for many applications. Some of these chips, while not military spec, can be repurposed for weapons or other equipment. However, this Chinese lifeline comes with important caveats. First, China's chip technology, while advancing, still lags in the cutting-edge realm. Chinese foundries like SMIC produce chips in the 14 nanometer to 28 nanometer range and have limited capabilities at 7 nanometers in small volumes. These are decent, mature nodes, but not the top of the line needed for high-end CPUs or AI accelerators. So Russia can import mid-range semiconductors from China, perfectly fine for things like appliance controls, older model cars, or basic telecom equipment. But for advanced needs, like high-performance computing or modern smartphones, China cannot fully replace Western tech. For example, Russia has been trying to acquire large numbers of NVIDIA's state-of-the-art AI GPUs, such as the H100, on the black market, because neither its own industry nor China's can provide equivalent capability. That Russia is willing to pay exorbitant prices for banned NVIDIA chips, up to $20,000 each on the clandestine market, shows the limits of what China alone can supply. Second, Chinese companies face risks if they are seen as openly violating sanctions. The US has made it clear it will punish entities that enable Russia's war effort. In fact, several Chinese electronics exporters were added to US blacklists for supporting Russia's military. US officials even issued stark warnings. If China's big chip maker SMIC were found supplying chips to Russia, the US would shut them down, using its leverage over semiconductor equipment and software. This threat is not taken lightly. Chinese firms remember the case of Huawei, which was effectively crippled by US sanctions. A Carnegie analysis noted that given Huawei's fate, it's likely other Chinese companies will be careful to observe at least the letter of Western sanctions. Indeed, China's government has its own calculus. It values support for Russia, but not to the extent of incurring devastating secondary sanctions on its flagship tech industry. Beijing has even implemented some export control laws of its own, for instance, restricting exports of certain advanced drone components and specialty materials to avoid appearing too lax. Thus, much of the China-Russia tech trade operates in a semi-clandestine zone. Smaller and mid-sized Chinese firms or shell companies in Hong Kong and the UAE are often the ones handling shipments of restricted items to Russia. This provides plausible deniability for larger players. For Russia, the consequence is that it can get a lot of good enough Chinese tech, mostly older generation, lower-cost chips, which keeps many civilian and military systems running at a basic level. For instance, Russian automakers have begun using Chinese engine control units and sensors so they can gradually resume production, albeit often assembling cars that are a mix of Russian chassis and Chinese electronics. Russian telecommunications companies are reportedly installing Chinese network gear where Western equipment used to be. However, the lifeline has clear limitations. One limitation is quality and sophistication. Many Chinese chips are designed for mass-market products and may not meet the stringent requirements of, say, advanced missiles or fighter jet avionics. There have been reports that some Chinese-made components delivered to Russia failed to perform as needed in high-stress military applications. Another limitation is volume and lead time. With the surge in demand, Chinese suppliers have increased prices. Russia reportedly paid nearly double per chip on average by 2023 compared to 2021, and delays are common. Also, some Chinese companies have quietly refrained from selling their very best chips to Russia, for example, high-end smartphone processors or the latest telecom chips, to avoid legal trouble, delivering only slightly older models. In essence, China's support has been a lifesaver for Russia's tech survival, but it is more of a lifeline to stay afloat than a path to cutting-edge revival. Russia is now essentially a client of Chinese technology, particularly for anything in the mid-tech realm, from 28-nanometer CPUs to basic ICs. This dependency carries geopolitical risk. If relations with Beijing ever soured, or if international pressure forced China to curtail exports, Russia would have no good alternatives left. Even with China, Russia isn't getting back to pre-war levels of technological capability. It's merely staving off collapse at a lower plateau of tech.